Does watching Ryan getting punched in the stomach make you feel like you just got punched in the stomach? Do cat videos make you feel warm and fuzzy on the inside? It's possible that these feelings are triggered by mirror neurons, which are a type of neuron that fire not only when an individual executes an action, but also when they watch an action being performed on someone else. Today we're going to teach you a little bit about mirror neurons, what they are, some experiments which tell us how they work, and how this relates to practical things in the real world, like autism and its diagnosis. Mirror neurons were discovered by accident. They were first observed by a group of scientists at the University of Parma in Italy. They were performing unrelated experiments on the brains of rhesus monkeys in the 1990s. They were using single-unit recording to measure the brain activity of the monkeys while performing particular tasks. Unexpectedly, they found that neurons fired even when the monkeys observed researchers moving their arms and not just when the monkeys themselves performed the tasks. The neurons that fired were located in the premotor cortex of the brain, the same area that's involved in planning and executing movements. This is also the same area that is activated when the monkeys perform the actions themselves. The neurons fire when the monkeys observe other monkeys performing the actions, and fire weakly when the monkeys watch a human performing the action. This discovery was an exciting one because the neurons were located in a part of the brain previously thought to be responsible solely for sending motor commands through the brainstem and to other parts of the body. The activity of mirror neurons suggests that they are not only involved in executing actions, but also in understanding the actions of others. But do these neurons exist in human beings? How do they function? And should we even care about them at all? There wasn't much interest in researching mirror neurons until their potential for understanding social interactions and disorders like autism were understood. Their role in self-awareness, empathy, gender differences, language, and learning has been identified. These neurons appear to play a key role in human interactions, generating a lot of interest in recent years. It has been said that mirror neurons explain the very things that make us so unique. Now we have Ryan to talk about some of the most pivotal studies on mirror neurons.
On the subject of experiments related to mirror neurons, the first one of note is by a scientist named Kaisers, and what he did was he took 14 male participants and placed them into an fMRI, and he exposed them to an olfactory sense, in this case a disgusting smell of butyric acid. And first he would have the participants go into the fMRI and be exposed to this butyric acid, and he would measure the response in their brains. And then he would have an actor, apart from the participant, they would view an actor smelling the butyric acid, and then they would analyze where in the brain that activated. And after comparing these two measurements, he found that there is a particular segment of the olfactory area of the brain called the anterior insula, which reacts to both the exposure to butyric acid and the viewing of someone else being exposed to butyric acid. Now what this shows is that there are mirror neurons within the anterior insula, which trigger both when you experience a sense and when you view someone else experiencing the same sense. And going off of this experiment, Kaiser then did an experiment including men and women, 14 again, but men and women. Once again, placed them into an fMRI, but this time he did a somatosensory stimulation. He took a feather duster and tickled the legs of the participants. And he did that while they were in the fMRI, and he took a measurement of their brain, and then he had them view an actor getting tickled in the exact same spot of the leg with a feather duster. And once again, he found that there's a particular segment in the somatosensory cortex which lights up both when you are being tickled yourself and when you view someone else being tickled in that same exact spot. So his conclusion with these two experiments was that mirror neurons are essentially the origin of empathy in humans, that having mirror neurons, it allows us to perceive the emotions and the pain and the experiences of others within our own mind. Essentially what he's saying is that mirror neurons allow us to perceive the experiences of other people, allow us to empathize with what they're doing and experiencing so that we can have more in-depth relationships and social interactions. In another experiment, there was a scientist named Iacoboni, or Iacoboni, I don't know, but he was a scientist, and rather than Kaiser being interested in the origin of empathy in humans, Iacoboni was more interested in how mirror neurons could allow humans to sort of anticipate the intentions of other people if essentially he was looking to see if mirror neurons also paid attention to the context of a situation rather than just the pure mechanical movement of body parts and experiences of other people. He wanted to know whether the context of a situation mattered to the mirror neurons and if different ones fired for different contexts. So in his experiment, he had 23 participants go into an fMRI, and he measured their brains as they viewed a video of a hand picking up a cup of tea. In one video, the hand was picking up a cup of tea from a proper tea party with cookies and a nice white cloth. And in the other video, it was picking up a cup of tea from a messy table covered in crumbs and slop and dirty plates and whatnot. And what he found was that the mirror neurons fired more strongly for the hand reaching out for the cup of tea in the context of an actual clean tea party than in the context of a hand reaching out just at a messy table to a cup of tea. And what this proves is that the mirror neurons do in fact understand the context of a situation, that because the neurons fired stronger for the proper tea party than they did for the messy table. So there's a part of the premotor cortex which is literally more tuned for a properly contextual tea party than a teacup on a messy table. And this essentially shows that mirror neuron activity is context dependent, that it is able to recognize individual interactions. The similar neurons will fire just at that motion, whether they're lifting up a plate or a teacup or what have you. But that there are specific neurons that are context dependent, and that means that mirror neurons work on a higher level than just purely analyzing movement or sense, that they do pay attention to context and that they do fire differently depending on the scene surrounding the movement or sensation.
Okay, so I'm gonna start by defining what neurorehabilitation and neuroplasticity are. Neuroplasticity is this idea that our brains are not static, so even past your developmental age, past your childhood, you're still able to change your brain. This is really important in neurorehabilitation, which is this idea that you can rehabilitate your brain after something has happened to it, like a stroke, for instance. So the importance of mirror neurons in this context is that mirror neurons are this huge discovery, not only in the fields of just they sort of apply to everything in the brain. And so they're mainly involved in imitation, and the highest concentration of them that we've found so far is in your motor cortex. So basically what that means is when you have a stroke and you're not able to use a certain part of your body, say it's your right arm, basically what they do is they go in and have you use this mirror that basically reflects it in a way that when you use your left arm, which is still functional, it appears in the mirror like you're using your right arm. And the reason that this works is because they've done studies that found that mirror neurons are actually part of the process of making motor memories, which means that when you watch someone doing something, you then have a memory of doing that action in your brain, which therefore allows you to make more connections in your brain, which then allows you to regain function of the area that was affected by the stroke more quickly. The way that they discovered that mirror neurons were able to perform this sort of function in neurorehabilitation is there was a study done by Katja Stefan, and basically what she did is she used TMS to inhibit the mirror neuron function in one group and allowed it to function in another group, so that she showed then that in learning a new skill, the group that were able to use their mirror neurons actually picked up the skill much more quickly than the group that was not able to use their mirror neurons. So, like I said earlier, this is like a huge application not only in rehabilitation of like strokes, but potentially it can be used sort of with many different physical impairments or other things that manifest themselves in brain dysfunction.
So we're trying to find what the physical manifestation of autism is in the brain. So we know people with autism struggle with language development, they struggle with imitating others, and they struggle on picking up on social cues. And we think that mirror neurons play into that because mirror neurons enable us to, our neurons fire when we see other people doing things. So that might give us the ability to empathize on that basic level, and that might inhibit that for people with autism. So mu is it's an electrical pattern that is continuously firing in the motor cortex of the brain, which is up here somewhere, and think dorsal, I'm not exactly sure, but it's up here. And mu suppression is what happens whenever you facilitate movement. So that can happen when you move, and through the study of mirror neurons, we know that it also happens when you watch other people move. So that's what we're looking for in this experiment. We're looking for the mu suppression. So the previous experiment done with mirror neurons to prove that mu was in charge, or well, not in charge, but involved in this, was they used macaques. And macaques, we used the SUR, single unit recording, and actually measured the impulses as they watched other monkeys making movements and did movements themselves. So we know that mirror neurons fire when macaques watched other macaques move. Ramachandran did a test where he took people with autism, high-functioning autism, and he took people without autism but were normal intelligence of the same age, and he pretty much hooked them up to an EEG, asked them to move their hands like this, asked them to watch a video of a hand moving the same way, asked them to watch a video of balls bouncing and a video of static. And the results from the EEG were that people with autism had mu suppression only when they themselves were moving their hands. Mm-hmm. And people without autism had the mu suppression when they moved their hands and when they watched the hand moving. So that tells us that people with autism have something different in their mirror neurons, like something isn't working, something isn't firing. So that's how we can make the connection.
Mm-hmm.